We asked our consultant to design the pump station to fit in with the environment.
To produce the 1,000 ring segments, it's going to take approximately 14 months.
When we're ready to put it in the hole, we rig it up and send it down the shaft, which is 600 feet.
Hello, welcome to the Sustainable Region. I'm Vanessa Timmer. Today we're at the Seymour Capilano Filtration Plant, walking the interpretive trail. All this is in North Vancouver in the beautiful Lower Seymour Conservation Reserve. The trail is about 2 kilometers long, and signs along the way, like this one, point out the many facts and features of this amazing site. You can walk over a reservoir filled with over 200 million liters of water, check out the amphibian habitat, and learn more about how drinking water makes its way to people throughout the region. This plant is the largest filtration plant in Canada, and with its network of filters, UV light, and disinfection system, it treats up to 1.8 billion liters of water per day. This project has been part of the ongoing effort over the past decade to upgrade and maintain our drinking water system. It takes a lot of resources and constant upgrading to meet the water needs of a growing region. Balancing the effects of large infrastructure projects with the local environment and communities can be tricky. This pond is a great example of finding balance. Nearby residents were concerned about losing this valuable habitat, and as a result, the plant layout was changed so that the pond could be retained. Metro Vancouver staff and volunteers then enhanced this wetland for animals like the red-legged frog and the long-toed salamander. Sustainable practices and public involvement are key to successful projects, but it isn't always easy, as we'll see in our first story.
Living next to a construction project is a disruptive experience. Metro Vancouver aims to educate neighbours in advance so they know what to expect. Nonetheless, a major construction project about to begin right next door is rarely seen as good news.
Well, I was angry when I first found out about this project because when we bought our home, we had a golf driving range behind us. Now we find we're getting a pump station.
We're on the site of the Barnston pump station. You can see it's right next to a lot of the residents that live in this part of Maple Ridge. They're looking over their back fences and seeing our project being built.
It hasn't been too bad. It's been noisy. You know, you live next to a construction site, so it's just one of those projects for the greater good, as they say, and it has to be done.
Today, rebar is being moved onto the site, and workers are tying it in preparation for a concrete pour, one of the quieter stages of construction. Everyone agrees. The vibrations of the sheet piling that was done in early 2012 to build access shafts to the tunnels under the Lougheed Highway was the worst phase of living next to this project.
I came out here onto my deck and the flowers were shaking, the house was shaking, and I had visions of major damage. And we had some damage, but thankfully the people from Metro have addressed the issues, and the concrete work that I had done in my backyard here is going to be replaced because it's cracked and it's sunk.
Metro Vancouver has been holding regular meetings with the neighbours.
We have a working group made up of community members who appoint themselves as being interested in the project and living nearby, and they advise us on what their concerns are.
Neighbours have expressed major concerns about noise once the station is operational and the pumps are running.
Because we're so close to the residents, we asked our consultant to design the pump station to make it as quiet and friendly to the neighbours as possible. Also, the water-cooled motors are a lot quieter. So the whole pump station has got soundproof louvers and things like that to make it quiet.
There's no such thing as a typical Metro Vancouver construction project, but it's fair to say that road closures are common. Construction noise is unavoidable, and delays are not uncommon.
6 months, 8 months 10 months, backwards now because of this delay and that contractor and this and that and the other. And this, I would just rather them just get in, do it, and be done with it,
Right.
Yeah.
At this site, the delay was caused by Metro Vancouver's goal of keeping the work as quiet as possible due to proximity to neighbours. Traditional pile driving is very noisy. So the plan was to use helical piles that are turned into the ground instead. After extensive and time-consuming testing, it was determined that the ground was too soft for this method. So, engineers decided to pour an extremely heavy base of concrete instead. And that wasn't the only change made to keep nearby residents happy.
They've made some alterations to the designs to give us a green roof with a slope away from us. It's excellent. At the end of the day, we can still have a security and the privacy that we really want to enjoy. Anybody that has to deal with Metro Vancouver, my advice to them would be don't overreact to what's about to happen. Get yourself educated, find out exactly what they're proposing and work with them.
Well, here's our lawn after 6 weeks of absolutely no rain. You can see how brown it's become, and that's not a problem because it's in summer dormancy right now, and we have every assurance that as we get into the autumn rains, it'll come back and be nice and rich and green. But the big concern is that people say, my lawn is dead. It's not dead. It's simply into a summer dormancy, and I can really assure you that if my lawn will come back, yours will too.
Metro Vancouver's drinking water comes from rainwater and melted snow that's stored in reservoirs in 3 mountain watersheds, Coquitlam, Capilano, and Seymour. Water is piped from the reservoir to treatment plants, and then the big job of getting the water to your tap begins. Metro Vancouver's new Port Mann water supply tunnel will replace a smaller water main to deliver water to communities south of the Fraser, like Surrey, Langley, and Delta. The 1-kilometer tunnel will double the carrying capacity of the existing main and is designed to withstand a major earthquake and the pressure of the river above it.
There's an interesting story behind these unusual concrete shapes. Like a puzzle, they combine to become something more than a collection of individual parts. But that will happen far underground beneath the bottom of the Fraser River. The finished product being manufactured by this crew will never be seen by the public. Nonetheless, these sections of precast concrete are destined to become an important piece of Metro Vancouver's water supply system as part of the Port Mann water supply tunnel.
For this project, we're manufacturing 1,000 ring segments. Each ring itself is made up of 6 different units, different segments. Each segment is 1 meter long. They are put together into the ring, which is, each ring is a meter long, and 1,000 rings make up the 1-kilometer tunnel.
The existing Port Mann water main is one of several key water supply links to municipalities south of the Fraser River. This new, larger water main will help ensure the continued, reliable delivery of clean, safe drinking water to these municipalities and will more than double the capacity of the existing main. Here's how it works. The water supply tunnel is being constructed underground, beneath the Fraser River. A TBM, or tunnel boring machine, will dig its way north beneath the river, creating the tunnel. Along the way, the tunnel liner sections are installed to protect and support the steel pipe that will eventually carry the water. The liners are made in Richmond at the Armtec precast concrete plant. The crew has been working for about a year, manufacturing the 6,000 individual sections required to create 1,000 ring segments that will line the 1-kilometer tunnel.
To produce the 1,000 ring segments, which are 6,000 units, it's going to take approximately 14 months. Generally, we produce 18 sections in a day, which comprises 3 rings. We do double cycle if schedule warrants, and we can turn over the forms twice a day to produce the 36 ring segments if necessary.
It takes 6 specially shaped pieces to form each ring of the tunnel liner. Once underground, sections of steel pipe are inserted inside the liner. The weight of the earth and the groundwater above the tunnel is considerable. The thick liners are built to withstand the extreme pressure far below the ground, protecting both tunnel workers and the water supply pipe that will be installed within it. Producing the 6 segments that make up one section of tunnel liner takes approximately 3 hours.
Form preparation is the first step. The forms are open. They are oiled with a bond-breaking material to keep the concrete from sticking into the steel form itself. From there, we make sure they're closed up properly with all the inserts in place. We take the final dimensions, do the quality checks, being a pre-pour sign-off, and then from there, after all of this is done and documented, we're ready to start pouring concrete. We bring the bucket of concrete over top of the mold itself, and there's an opening in the top of the mold. We pour the concrete in while using external vibrators to consolidate the concrete properly into the mold. After the mold is filled completely, there's a small amount of external vibration just to finish off the consolidation. And then after that, we screed that open area. Once the concrete has got a certain amount of set so we can open the form without anything sloughing away, we open the back ends of the form, and from there we screed everything to its final dimension and put the final finish on it.
Each batch of concrete is tested before the concrete is poured into the form to ensure that it meets specifications. The concrete is a relatively dry mixture. An innovative feature is the use of steel reinforcing fiber rather than the traditional rebar cage. These tiny slivers of metal do the same job as traditional reinforcing steel, giving each segment additional strength that can't be achieved with just concrete alone. A crucial step is demolding, when the concrete segments are removed from the forms where they were cured. A vacuum lift is used to make it possible to hoist the concrete liner with its smooth, curved surfaces. Each piece must be flipped 180 degrees and then stacked on a pallet for storage until it's needed at the job site. A total of 6,000 individual sections will be produced, creating the 1,000 1-meter wide rings, which will line the kilometer-long water supply tunnel. The final manufacturing step is to glue the gaskets that will provide a seal between the sections of the ring. Once installed, the space between the concrete rings and the inner steel pipe will be filled with cellular concrete.
McNally, Aecon, and Armtec have worked together before in the past, and on this project, right from the onset, we got together and partnered on it. And in pulling our expertise, it really helped in making this a successful project.
The project is expected to be completed at the end of 2015.
Welcome back to the Sustainable Region and the Clearwell area at the Seymour Capilano Filtration Plant. Although this may look like green space, It's actually a green roof that sits above reservoirs filled with 200 million liters of fresh, clean drinking water. That may seem like a lot, but the average Lower Mainland resident uses 325 liters of water per day. To help meet that demand, this plant was built to treat the water from both the Capilano and Seymour reservoirs. And in 2004, construction began on the Twin Tunnels project not far from the spot. Each of the twin tunnels measures 3 meters in diameter, 7 kilometers long, and as much as 600 meters below ground in some places. One tunnel brings untreated water to the plant, and the other returns clean water to the communities in the Capilano area. These massive tunnels took 6 years to excavate, and it's taken another 3 years to put the supports in and line the tunnels. But the project is nearing completion.
Our pipe is stored at Anasis Island. It arrives on site. When we're ready to put it in the hole, we back it under the gantry you can see behind me. And then we rig it up and send it down the shaft, which is 600 feet.
All these guys, they've all been with us a long time and they all work well. To lower them down the shaft, that'll take another 45 minutes. And it's all slow and steady, and that's the way we like it. We knew it was going to be tough. It was a puzzle, and we cracked it early on. In the future is something we can tell our grandchildren about.
If you're looking for a nice hike, check out this interpretive trail. You'll enjoy nature, and you'll find out more about how drinking water gets to our residences and businesses. Thanks for joining me. That's everything for today's show, but you can watch these stories and more at our blog at metrovancouvervideos.org. For the Sustainable Region, I'm Vanessa Timmer. See you next time.